We are given the maps of these two functions f and g, and we are asked to create the composite function map f of g. So the first thing I like to do is expand this out and rewrite this as f of g of x. Okay, the first thing we're going to do, folks, is we're going to recreate g of x. So we're just going to put these inputs here and these outputs from g. Okay, now here's the problem. F can't work on that 4. Look, 4 is not part of the domain of f. So we're going to cancel out that 4 with respect to the fact that f can't work on it. Now we're going to backtrack and we're going to ask ourselves what input into g led to that 4, and it is none other than 2. So we're going to go ahead and remove 2 from the domain of the composite function. So now what happens is, if I rewrite this as f of g of x, the final domain of the composite function is just going to be these 3 inputs. Okay, now let's look at the final output of the composite function. Well, these are the only inputs that are going into f. So if we input 0, we're going to get 2. Sorry. If we input 0, we're going to get 2. And if we input 2, we are going to get 8. So folks, these are the final outputs of the composite function. So notice what happened. The domain of f got reduced. The only part of the domain of f that was used was the 0 and the 2, because they were indeed created by g. But this part of the domain of f is not used in the composite function. Next, we are asked to find the composite function g of f of x. So let's go ahead and rewrite this, g of f of x. So that means we're going to work on the inside function, which is f of x. Normally I would rewrite it, but it's right here for us, so let's use it. Okay, so let's examine what happens here. F creates these outputs, 2, 5, 8, and 11. Unfortunately, g, which comes next in the composite function, the only one of these outputs from f that g is able to work on is the 2. So this gets plugged into g. These don't. So if these can't get plugged into g, then this cannot be part of the domain of the composite function. So because they lead to these outputs that are not inputtable into g, if that's a word. Okay, so now when we put 2 into g, we can see that the result is 4. So, folks, this is a very limited domain and range. Look at this. The only thing that's left in the domain for the composite function was 0, and the only output from the composite function was 4. So this is your final mapping from 0 to 4. That is for that composite function. Next, we are given graphs of f and g, as well as this table format, and we are asked to find the domain and range of the composite function g of f of x. So you see here, f of x is created first. Here's the inputs into f of x, and here's the outputs. Now, the only outputs I'm going to consider from f of x are those that we are allowed to plug into g. So let's look at these individually. So can I plug in 2 into g as an input? Yes, I can. G of 2 exists. G of 2, the y value is 1. So that's okay. Now let's look at an input value of 1. Can we plug in x equals 1 into g? Yes, we can. The output would be -2. How about 0? Yes, we can plug in 0 to g. the output would be negative 3. Can we plug in 1? Yes, we already know that. That's going to be negative 2. Can we plug in 2 to G? Yes, we can. We already know that. The output is going to be 1. Now, how about 3? Can we plug in an input of 3 into G? The answer is no. So, if we can't plug in the output of 3 into G, then this input is excluded from the final domain and range. So, folks, quite simply, this is going to be your domain here for the composite function, right here, and this is going to be your range. So for completeness sake, let's go ahead and formally write the domain as the interval between negative 2 and positive 2 inclusive, and the range is the interval between y equals negative 3 and 1 inclusive. Even though the integers are only listed here, we could see these are continuous functions, so every point in between would apply. Again, when we do the domain, you always go from left to right, and when we do the range, we go from the lowest value to the highest value. Okay, next we are asked to find the domain of g of f of x, already written the way I like it. Okay, we're going to work on the inner function first. Here it is. Here's our inputs into f. Here's our outputs from f. Now, we can only use we can only use 1 and 2 from the output of f into g. So we're going to use those inputs into g, and our outputs from the composite function are going to be here. Okay, so because this is not part of the input into g, we're going to exclude that input into the composite function. So our final domain and range are going to be, our domain is going to be what's left of the original domain of f, that's 0 and 2, and our range is going to be the output, negative 2 and 3. Why is this not included? Why are we going to cross this out? Because this input into G was never generated by f. So this is never going to be part of the composite function. So here is our final domain and range, respectively. If you want, you could put a set notation here. Notice that's not a bracket, because this is not an interval. That set notation indicates that it's just these individual components of the domain and range.